by this relative motion concept. It's very important, right? Because so far what we looked at is the motion of one single rigid body. We looked at problems, remember projectile motion problem, you look at only one bullet. And we solved the problem of motion curves. It's all one particle executing rectilinear motion that we looked at. We looked at some of the curvilinear motion problem. We looked at that is only one particle. But the relative motion concept is very important is because we may have an observation. So what is that so far we have done is we were been observing accelerated bodies being from a fixed reference. In a rectilinear motion, we had a point O, which is reference, and then the distance here 1 meter, 2 meter, and so on. This is path, so x direction. Or it can also be vertical motion, like bullet fired vertically up and it goes and comes, that's y direction. So I can have this as my reference. Here this is my reference, 0, 0. So here it's only x coordinate, here only y coordinate. These are called a rectilinear translation. Right? Why I put this here is we look at from this fixed reference. This is called a fixed reference. This is called a fixed reference. So I am looking from here, what is the motion of my rigid body, and its physical geometry is neglected, so particle kinematics. So in projectile motion also we have fixed a point A, and then we are looking at its path. So it goes like this, right? So this point is 0, 0, it's fixed. So fixed reference, if we have and you look at an accelerated body, that motion is absolute motion. We know how to handle it. But now there are situations, there are design requirement of mechanical system which are having more number of elements under motion. If I take an IC engine, I have an engine has got many number of components. Piston is reciprocating, connecting rod is undergoing curvilinear translation as well as rotation, and then crank is rotating. So I have different elements undergo different motions. If you look at the competition, our students have gone and secured 4th position in what is that? Unmanned aerial small vehicles, aerial vehicles. So that is all. If you see, there are 2 participants are there. There are 2 elements will go. So that 2 competitor being from the fixed reference can look at it. That is their individual absolute motion. But if you look at real-time scenario of fighting scenario during war section, you can have the number of aircrafts flying up. So there are a group of aircrafts of our own, and there are a group of aircrafts of enemies. So if you look at, it is important that the pilot who is now in our fighter flight looks at this enemy's flight, but the reference is now for him is not fixed. He is also accelerated on the sky. And of course, we will have a control room in the ground. That is our fixed reference. So the person who is having his task from the control room and watching all the aircrafts in the sky, and he pass that important messages, communication taking place. That is observation from the fixed reference like this. But the communication, whatever he says, the pilot who is flying in the aircraft, looking at an enemy's aircraft, which is also accelerated, that is what is called a relative motion. So looking at another accelerated body from the moving frame of reference, when you look at, there comes a concept called a relative motion. So that's what you have to say. So when is this relative motion that comes? Observation of accelerated bodies from the moving reference. From the moving reference. So moving reference is also accelerated from the moving reference. If the moving reference is not accelerated, it is going in a straight line in a constant velocity, then it is same as that of fixed reference because it is not accelerated. But when you have a curvilinear motion, we looked at even velocity constant, your acceleration is exist. So anything that goes in a curved path is accelerated motion. If a rigid body is translating in a straight line with the constant velocity, that is as good as again fixed because it's not accelerated. So you are on a constantly moving velocity vehicle or fixed reference. You look at another vehicle which is traveling. It is as good as one and the same absolute motion. That is what it will appear. Right. So that's what you should understand. So what is the difference between fixed reference and the moving reference? So observation of accelerated bodies from the moving reference brings in the concept of relative motion. Again, this study is easier, simplified. This study is simplified if physical geometry of bodies are neglected. So what will happen? That is neglected. I have only particles in the sky. So one particle A going. So I can imagine now. This is my fixed reference X, Y. I'm generalizing. So this is my fixed reference, and I have one particle A undergoing motion here, and I have another particle B undergoing motion here, and this curved path and this curved path. So the moment it is on a curved path, that is translating. That's called a curvilinear translation. It is accelerated motion. So I have a fixed reference. So being from the fixed reference, this is fixed.